Hello students, in this video we are going to see the linear programming binary application, which is capital budgeting. So let me take you to capital budgeting chapter now. It is in applications of integer linear programming chapter 7, and you will see here application involving 0 1 variables, which is also called as the binary variables. So we have applications which is for capital budgeting, fixed cost, distribution system design, bank location, etc. So we are looking into capital budgeting, right? So applications involving 0 1 variables, the variables which take only two values. It can take a value 0 or it can take a value 1, right? So usually we are going to use it like, for example, uh, variable equal to 1 if the corresponding activity is undertaken. Variable equal to 1, corresponding activity is undertaken. If it is 0, then the corresponding activity is not undertaken, right? So basically when we look at the capital budgeting example, the example goes like this. The ice cold refrigerator company is considering investing in several projects that have varying capital requirements over next 4 years. Faced with limited capital each year, management would like to select the most profitable projects. The estimated net present value for each project, the capital requirements, and the available capital over the 4-year period is given in table 7.1. So this is the table where all the information is available. So if you look at that, there are 4 projects under consideration: plant expansion, warehouse expansion, new machinery, and new product research, right? And the present value of these projects, that is the net present value of the projects, is $90,000 for plant expansion, 40,000 for warehouse, 10,000 for new machinery, and for new product research 37,000. And then yearly capital requirements, year 1, 2, 3, 4 for each project is given here, like 15,000, 20,000, 20,000, 15,000 for plant expansion. Whereas with new machinery we require right now 10,000, and then we require in year 4 4,000. So new product research we require 15, 10, 10, 10. And the total capital available with the organization, which can be used, is year 1 40,000, year 2 50,000, year 3 40,000, and year 4 is 35,000, right? So now how to proceed? Basically we want to find out the best combination of projects which will maximize the returns, or which will have the maximum present value. So let us take 4 0 1 decision variables. P for the first one, this is for plant expansion P, then W for warehouse expansion, then for machinery they are using M, and for new product research they are using R, right? So if this variable takes a value of 0, then that particular project is dropped, which is not considered. If that particular value is 1, that means we are going ahead with that particular project. So that is what is explained here. If P1 plant expansion project is accepted, 0 if rejected. Now how to formulate the model? So usually when you want, the first step is to formulate the model, and then second step is to use Excel solver to solve it, right? Sometimes in the exam you don't have the Excel available, then you will be have to just develop the model and put it on your answer sheet. So for first one, the capital budgeting problem, we are going to first, our objective function is to maximize this present value for all the projects, right? So right now we are using the entire, all the values will be in $1,000. So 90 times P plus 40 times W plus 10 times M plus 37 times R will be the present value for the entire proposal, right? And obviously if P becomes 0, then that particular project present value will be again 0, right? If P1, then that particular project value will be that particular value. So we are going to use these variables everywhere in all the equations. So if the first equation is $40,000 is our total available capital, so 15 times P, 10 times W, 10 times M and 15 times R, when you add that, should be less than or equal to 40, right? So that is what our year 1 capital available constraint. Year 2 is for this 20, 15, 20P plus 15W, nothing here, and 10R. So like this we construct all the 4 years the capital requirement constraints. And finally the most important thing, very important thing, is that this all 4 variables should be written as a binary variable, 0 1 variable. So they should be written as 0 and 1. PWMR should be 0 and 1. So this particular entire this is your project model, or this is your capital budgeting model, right? So in case they are asking you just for the model, just start declaring your variables like this. From here your answer will start, and then this will be your actual answer. If you don't write this, then you will lose marks heavily, because this is the heart of the entire model. So this is how we do the capital budgeting modeling. And I have given you so many different videos where I have explained you how to solve the LPP using solver. So there you can use this model and set up that particular problem there and solve it. And the answer you got here is, in this case you are getting R equal to 0. So that means what? The research will not be going ahead. So obviously P, W and M will get values 1 and R will be 0. And then that is what is going to be the so 90 plus 40 plus 10, 140,000 will be your maximum net present value for this 4 project, because 1 project of research will be dropped. So this is what is the application for capital budgeting. Thank you.